All right, now this is 10.5 integrated geometry, and we now look at the angle relationships in a circle. We have several cases that you will see the relationship of the angle and its circles. Here we go. First, we'll look at the angle that is made up by the tangent and a chord that they intersect one point together. Suppose you have a chord right here, okay? Angle with the center C. Got it? Now, it's all right, angle with the center. Now, what if you have right here is the angle right here. All right, this is, suppose you have a chord, and that chord is BA. Got it? And now, what if in this chord right here, you have the tangent line to the circle at the point what? At the point B. There we go. What if you have right now as the tangent line to the circle at the point B? There we go. And they make this angle right here. Let's call this is angle, this is angle 1, and this is angle 2. There we go. You see that, guys? Okay, all right. Now this is the tangent line to the circle at the point B. And then the chord AB, and point B is on the circle and point A is on the circle. Then what is the relationship? What is the relationship between the angle to the circle? Now, this is what mathematicians have figured and they proved it. Angle 1, okay, can you see it? Angle 1 will equals 1/2 of the minor arc AB, okay, which is M minor, okay? Minor arc, you just use AB. There we go. Got it? All right, the measure of the arc AB, angle 1 in this direction. Got it? Can you tell what is the measure for angle 2? Angle 2 right here. Can you tell me right away? Yep, angle 2 is 1/2 of the major arc. Okay, let's put a point C right here. Okay, so that you can differentiate the minor arc and the major arc, which is arc B, or you say ACB. ACB. That's it, guys. That is the relationship between the angle that is made up by the tangent line and the chord at the point of tangent C. And that's how the angle is relating to the circle. That's right there. Okay, got it? And example 1. Let's say if angle 1, we want to know what that is. Okay, if you are given the minor arc, if you are given the minor arc is what? Is let's say it is 130. If you are given the minor arc AB 130, what's angle 1? I know, I'm insulting your intelligence. If the angle B, you're looking for what is the measure of the angle, you don't know, but you know the arc AB, minor arc AB is less than 180. So that's 1/2 of 130. What is 1/2 of 130? Come on, that's right, 65. Okay, for some reason I ask, well, then what is angle 2? There we go, angle 2. And you ask, Mr. Dan, come on, stop insulting us. Well, angle 2, if the whole circle is 360 and minor arc AB take 130, what is 360? What is 360 minus 130? Yeah, 0, 3, and 2. Oh, so the whole thing over here is, yeah, this guy over here, right here, that is what? 230. Therefore, angle 2 is what? Angle 2 equals what? Can you see? What is this? It is 115 degree. Perfect. To check to make sure, 115 at 65, that's perfect. 180 right there. You see it, guys? Makes sense. Perfect sense right there for you. Now, this is case 1 when you have an angle that is made up by a tangent and a chord at the point of tangent C. Move into another direction, another case, you have different scenario. Let's see what it looks like. Look with me in theorem 10.12, okay? 10.12, what you have here? 10.12 you have right here with me. Let me see. Okay. 10.12 you have, oh, what if the angles inside the circle? Here we go. The angle made up by the two chord. Let's say, look at this. Okay, chord, one chord, two chord. Okay, let's call this is A, C, and this is B, D. There we go. And made up two angle 4, but just one right here, and this is angle 2. All right. If this is the case, ladies and gentlemen, what is angle 1 would look like? By nature, angle 1 will be the half of the sum of their intercepted arc. There we go. See it? Angle 1 is half of the sum of the arc DC add with the arc AB. That's it, guys. There we go. Perfect. They put M right there, meaning the measure of the angle, just to get you clear that this is the degree of the arc, okay? M stands for measure of the arc, okay? What about angle 2? Can anyone shout it out? That's right. Angle 2 is same thing, which is 1/2 of, that's right, the sum of their intercepted arc, which is in this case is what? AD. AD plus what? That's right, arc BC. There we go. Okay, are we good? Now, just to check to see if you guys really understand this. For some reason, I want to find angle 2. Can I call it x 0 degree? Which is, I want to find the degree of angle x. What is it, Mr. Dan? Well, you are given that, let's say, right here, AD. AD is 130 degree. There we go. AD is 130 degree. Then what is, BC? If this is already known as that, then BC is what? Yep. If over here you have is, let's say, if AD right now, look, if AD is given 1, there we go. If AD is given 1, let me see, okay, I'm just checking to make sure. First of all, angle 1 is measure DC at AB. That's right. Angle 2 is AD at what? BC. Okay, that's correct. Okay, now look over here. You want to find measure of the angle X. And you now given, let's say this is right here as from B to C, just from B to C right here. There we go. From B to C. Haha. Wow, this is cool. From B to C, and B to C is what? 156. There we go. From B to C is 156. All right. Okay. Well, they gave us LK. LK is that. And, okay, there we go. Okay. This angle at that angle right there. Okay, that angle DC. And then you have AD at what? At BC. Okay, I'm good. Okay, now, how do you find, I'm working on example 2, just, so you know. To find angle X, what do you do? Angle X equals 1/2 of what? X 1/2 of, there we go, measure of arc, intercepted arc BC add with measure of arc AD. There we go. Now look, do we have those two values, guys? Yep, insulting your intelligence again. So there we go. Now, with that in mind, you have now 1/2. BC is 156. AD is 130. Okay, task is done. So add them all together, divide by 2, what you get? 143. There we go. If you know this is X is 143, what is 1? Yeah, you take 180 minus that, you get it. If that's 143, what is this? You see, all related in the circle of life. All right, we're almost there. Let's move into another case of the relationship of the angles and their circles, which is bring me to the next theorem, which is 10.13. Now look at this right here. 10.13, you have several scenarios, but the same principle being applied. Let me erase this, okay, guys? Okay, here we go. All right, let's see it's all there. Okay, look. Now we have the circle. Now the angle is outside of the circle, and that is a tangent and a secant, or two tangents or two secants intersect outside the circle. What would that look like? Shall we? You have a point out here, and first of all, let's go for a tangent line to the circle. Look right here. There we go, tangent. Okay, now that right there. Let's call this is right here tangent C at the point of tangent C. Okay, and then you have a line that really cut through the circle just like that. There we go. Okay, and this out here is called angle 1. This angle is made up by the tangent. Okay, by the tangent that contains C, and then the line AB. This is called A, this is called B. Then, ladies and gentlemen, this angle right here, angle 1 equals what? What is the relationship of angle 1 right here? Look at this. You see the two intercepted arc? You see it, guys? Run right there. Look. First, this is the smaller arc. Got it? And second one, this is the bigger arc. Okay, so you see two arcs right here made up the angle that is outside. The vertex is outside of the angle, outside of the circle. And this angle made up by the tangent line and the chord, or the line, and the line runs through the circle at 2 points. Then what is the angle 1 relate? How does it relate to this, nature right here? Angle 1 is 1/2, will be half of the difference of the intercepted arc, which is the bigger arc BC minus the smaller arc, what? CA. M stand for, measure of the degree. There we go. That's how you do it. Okay. Now you say, but Mr. Dan, what if you have really a vertex outside of the circle, and they are no tangent to the circle at all, but just cut like this, Mr. Dan? What would that look like? Ladies and gentlemen, same principle apply. There we go. Suppose if this is angle 2, okay, and this is, let's say, point A, this is point B, this is point C, this is point D on the circle. Then you would say, Mr. Dan, what would angle 2 look like? Same principle apply. You see it? Yep, same. Which is what? 1/2 of the difference of the, there we go. There we go, the two intercepted arcs. And that is the difference of them, which is measure of CD, take the bigger arc, minus the measure of the smaller arc, because you want to have a positive value. There we go, guys. There we go. Same thing right now, and you now see that right there. Okay, you got it? All right, the next one. What's case number 3? Mr. Dan, you got one tangent, one line runs through circle at 2 points. You got two lines run through the circles at 2 points. What if you have two tangents, Mr. Dan? Haha, two tangent. That's all right. Let's go. Let's go with two tangents. See what it looks like, okay? Now, let's take away everything. Whoa, you hear that sound? Yeah, sorry, guys. Okay, what if now you have two tangents running through the circle at, and they make an angle outside, the vertex outside of the circle. Let's call this is angle 3. Okay, this now point, let's call point right here is, two tangents, okay? This is, how about you call it, what do you call it? X, what? Y, angle. There we go. And here is your circle. There we go. See it? I can do circle. Okay, perfect. Can you see it? Now, case 3. Two tangents to the circle. What would be like for angle 3? Relate to this, nature situation. Same thing, y'all. Same thing. 1/2 of the bigger arc, bigger intercepted arc, which is measure of xy. xy. See it, guys? xy, okay? Which is the, make it clearly, if this is the bigger arc, then let's just give it another name. XVY to represent for the major arc. XVY. You see it? Hey, did you see V down here? Okay, let me call V right here. Look, on the point right here, I call it V. So the major arc XVY. Major arc XVY minus the minor arc XY. There we go. Now, the task is done for you. 10.5. Okay, you see it? Pretty cool. And the application, guys, it is an example 3. Shall we do example 3 together? Okay, let's go. Example 3. All right, in example 3, I'm going to erase the board because I need, space to do example 3 with you. Turn your page to 682, okay? All right, so you now get the principle of that. So let's go. All right, this is how Mr. Deng draw the circle on the board. You see that, guys? The circle is made up by 2 semicircles with the same diameter. So look, it looks pretty well, perfect on my scale, but on the screen, since, it's still the board. So look right here. I am going to draw what example 3 has for us. We have a tangent line to the circle at the point D. There we go. Okay, and then over here you have a line that runs through the circle just like that. And then they ask for, Mr. Deng, what is angle X right there? Knowing that the arc, the minor arc right here, let's say this is what? This is B. Okay, and this is A. I'm getting used to this. Okay, here we go. And they gave us the minor arc, BD right here is 76 degree. Oh, and they even gave us this guy right here, AD, okay? ADA is what? Are they insulting our intelligence, guys? Not to be prideful, but this is like, are you kidding me? This is 180. Okay. All right. So what is angle X? I just told you angle X is 1/2 of the big arc, which is 178 minus what? Yeah, hello. They really insulting you guys and me too. Not to be too proud, but there you go. So what's the answer here? That minus that give you? Okay, that's right. That is 102, right? 102 divided by 2 give you 51. Indeed. You got it. Example 4 is just another solution for you. It's self-explanatory, and I think you can ace that in no time. Go for it, guys. I'll post homework for you on 10.5. Okay? See you next video, which is 10.6.